So we have a lot of tools to cover in this practicals. So I'll be a little bit fast, and there are this lab manual gives all the commands that will be required. Okay, so for example, if you go to GitHub, you can see over here there are many commands, but we'll only run those which are highlighted in red. Okay, you can try. The description and how to use that command is also given. So for example, this command is not highlighted in red. Okay, but you can try this at home if you want to. Okay, the description is very clear to remove remote repository actually. Uh, should be. Okay. Uh, so I said it was clear, but it wasn't. Anyway, but you get the point, right? To remove remote. If you have added a remote repository, the next was to remove a remote repository. But we'll not cover that because it will take time. Okay, so we'll cover only those highlighted in red. Okay, so to save the time. All right. Uh, all right. So software configuration management using Ansible, provisioning mostly using Ansible or Puppet. Okay, so any one of these two. So we have many tools to cover. So we have seen, which we'll see in the diagram, of course. Okay. Uh, the term of description is also given over here. 25 marks, 15 marks for experiment, 5 marks for assignment, and 5 marks for attendance. Okay. All right. So we'll close this syllabus copy and go to our lab manual. So I hope you have lab manual opened over here with you too, or else you can just refer to the presentation that I'm giving right now. So if you click on Introduction to DevOps, I've given the source also from where I've taken all this data. So you can either refer to the original source or you can refer to this lab manual. Okay. So what is DevOps? DevOps is basically a methodology. Okay, it's a methodology to uh, speed up your software development life cycle. Okay, now if you have seen, it's a combination of two words. Okay, DEV, which stands for development, and OPS, which stands for operations. Okay, so these are two steps combined in one. That is DevOps, that is development and operations. All right, the development and operation. So first is the waterfall model. Waterfall model, as you know, all the properties, it's a sequential top-down model, and there are various stages: requirement gathering, software implementation, testing, deployment, and maintenance. And every step has to be preceded by its predecessor. You cannot skip a step, right? And you cannot go up the waterfall model, right? The reverse process is not possible. You only have, because water flows only from in one direction, right, top to bottom. So you have to follow one flow of your software development cycle, right? So uh, that's about waterfall model. It took a lot of time. Usually this was used for developing projects which have stable requirements, which is not the case in today's world, right? Today the the requirements change very frequent. So the next thing that came along was agile methodology, which promoted continuous integration of development and testing, right? So in agile there were various iterations. Each iteration has planning, coding, and testing. Planning, coding, and testing, right, in iterative fashion. So it brought some agility to the development, but not the operation side. On operation side, I mean, if you had to, it was not that in agile methodology, after every iteration, there was a release, stable release, right? So agile methodology, you implemented a module, then you tested it for bugs, repaired those bugs. In the next iteration, you repaired those bugs, and then you made some more changes and so on, right? But you did not release a stable release, right? So that was the lack in operations part, right? And there was a lack of collaboration between the developers and operation engineers, right? So this is what DevOps focuses on. Okay, so the term I have, as I've explained, is a combination of both. The life cycle has these following stages. There is continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. Okay. Now, continuous is written because there is no time lag in between. Okay, so once you are done with the development and you uploaded your code into GitHub, for example, right, it is with no time to spare. It is directly tested. If your test scripts are ready within Selenium, it will be directly tested. Okay, it will be directly sent by Jenkins, that is your configuration continuous integration server, to your testing servers. If the tests are successful, and if you have configured your integration server to deploy it directly to your deployment, your production servers, then after successful testing, it will directly deploy on to your uh, production servers. Okay, and then continuous monitoring, of course, to see if there are any problems that occur in when the code is when the application is running. So okay, so that is why continuous is written after before every stage. That is it is continuous. There is no time lag in between. Okay, so these are the stages. You can see control. There is version control for source code, something called as source code source code management. Then continuous build, which will compile, validate, and review your code, which will perform unit testing, integration testing, and so on. Okay, then there is continuous delivery, that is continuous integration. Continuous testing using something called as Selenium. Okay, then there is configuration management and containerization, and all this is all orchestrated by something called as continuous monitoring, which is uh, done by Nagios. Okay, all right. So we come to this main diagram, which is DevOps, all the tools that will use in various stages. So for planning, we don't have any tool as such, but for coding, we have Git, we have Subversion, we have Jira, right? Then we have so we are going to see Git and Subversion over here, right? So tools over there, right? In building we have Maven, right? Maven and Gradle, but we won't see because it is not in your syllabus and it will take time. Testing, you have Selenium and JUnit, again not included in the syllabus. Integration, once you're done with the uh, uh, dev side, that is the development side, you go on to the arrow takes you to the next side, that is the uh, integration. The operation side. Okay, so this is all orchestrated by Jenkins. So, for example, if you upload a code using GitHub on GitHub, the Jenkins server will fetch that code and give it for building to Maven or Gradle, for example. And that after that code is built, it will be again fetched by Jenkins and given to test servers, where it will be tested using Selenium or JUnit. Okay, after it is successfully tested, it will be passed on to the deployment server, which is Docker or Docker. Okay, and then operations will be performed. Say, for example, if the operation, so Docker uh, or the operation side. Uh, uh, Operation side contains Docker, Puppet, and I think this is. Okay, Chef, SaltStack, Ansible. All right. So deployment and operations. Deployment we'll see using Docker. As I said, there are two practicals which are in your syllabus and which are developed using Docker. Then there is continuous monitoring using Nagios, monitoring to see whether there is any failure. So, if, for example, there are 100 servers and a server out of them fails. So, which server has failed? What error has occurred? That all that data will be actually uh, provided to the system administrator. Okay, so that details of that failure will be notified to the system administrator, and the system administrator will uh, uh, plan accordingly. All right. Also, load balancing or scaling up will be done using Docker. We'll see those all those stages. Okay, what they are. So, continuous development. In this stage, we have planning, coding, and building. Okay, so of software for planning there are no tools. For coding, code is maintained using version control systems. We'll see what version control tools are in the next uh, uh, experiment. Okay, uh, the first experiment actually, right? Then maintaining the code is referred to as source code management. Most popular tools are Git, SVN, Mercurial, CVS, Jira, right? Tools for building are used. These are Ant, Gradle, and Maven. Basically, what they do is package your code into an executable file. Okay, so they make a WAR file or a jar file or an exe file out of it. Okay, and they pass it to the uh, testing servers for testing. Okay, they don't actually, integration servers does it, but they prepare the executable file. All right. Then there is continuous testing. This in this stage, as the name says, the software is tested for bugs. Okay. Automation testing is tools such as Selenium and TestNG and JUnit are used. Okay. Basically, what is done is test scripts are written. Okay. Uh, and if the test scripts are ready, within no time the test scripts start running on the uh, code that the user has, sorry, not the user, the developer has developed. Okay, so that code that the developer has uploaded, that code will be uh, tested with the use of Selenium, TestNG or JUnit. Okay. After testing, there is something called as continuous integration. Now, continuous integration does not actually fall in this line, uh, but I have added it in between because you can see it actually orchestrates everything. Okay, so it takes the code from GitHub, it passes to building software that is Maven, then it takes the build exe and it sends it for testing to Selenium. If Selenium is, if there are no bugs, then it sends it to Docker Hub for deployment. Okay. Then, if there are some configuration management issues that need to be dealt with, then those Ansible and Puppet do those things, right? So this integration server actually keeps track of what is going on. Okay, so that is why I've actually included it in between. Okay. So the tools that are popular in this category are Jenkins, Bamboo, and Hudson. Okay. Uh, so it says over here when there is a change in Git repository, Jenkins fetches the updated code and so on. Right. Anyway, so then there is continuous deployment. Continuous deployment is the stage where the code is deployed to the production service. Okay. Now, configuration management and containerization, these are two uh, stages. that occur. Configuration management is where I'll just read through it. Okay. It is the act of releasing the deployments to the server, scheduling updates on all the servers. So basically, what it says that if, for example, uh, uh, previously the version of Java used in planning, coding, testing, and say deployment, and every stage was similar. But then the programmer or the developer updated to a newer version of Java. Okay, and now that version of Java should be present everywhere, right? That is the requirement, because otherwise, if there is a chance of failure, right? So, uh, in order to ensure that this configuration is followed everywhere, there is something called configuration management, okay, which is done, and that is what is given over here. That, basically, what that ensures is that same update, okay, Java update is given to every each and every step of this development. So, for example, the development if the development servers have updated the version of Java, that same version will be present in building phase. That same version will be present in the production servers. Testing servers won't require that, most probably, because Selenium will be doing that work. So, uh, to update that version of Java is the work of something called as configuration management system. Okay, and there are tools famous. Those are Puppet, Chef, SaltStack, and Ansible. Okay. As I said, we'll be seeing Ansible in this category. We'll be learning mostly Ansible. We'll also use Puppet if time permits, or we'll see configuration management for both configuration management as well as provisioning. One more thing that is not mentioned over here is provisioning, as I said. Provisioning is where if you have to maintain different requirements for different servers. For example, if the development servers require, say, Lampstack, that is Linux, Apache 2, uh, M for MySQL, right? And P for PHP. Okay, these four for web application development. And testing servers actually only require Selenium, okay, or maybe they require yeah, only Selenium, right? Okay, but and production servers which come on this green side, they require only PHP and sorry, they don't. Yeah, they will actually require. Let's take another scenario. Okay, let's take another scenario where some say Java needs to be installed. Okay, Java needs to be installed on developer's end. Okay, uh, and Java then say your database, okay, that is your MySQL. Uh, all these things are required. Uh, then these are the requirements of the production server. Sorry, what am I saying? This development server. Okay. Then for testing, the testing servers require Selenium only. Okay, they don't require Java, as I said. Okay. Then on your production servers again require Java for uh, deploying it, and they apart from that they require Apache 2 for hosting that web page. Okay, so require this different set of softwares. Okay, list of different list of softwares that need to be installed in different set of servers. Okay, is something called as provisioning. Okay, this maintaining this different list of softwares for different list of servers. Okay, so your development side will require certain set of softwares, your testing side will require certain set of softwares, and then your deployment or your production servers will require a different set of softwares. Okay, is called as uh, provisioning. Okay, this act is called as provisioning. Then there is something called as containerization. Containerization is where you can think of it, if we talk in terms of Java, it will be something called as encapsulation, right? It will be similar to encapsulation, right? Containerization basically means you bundle everything, all the your application along with all the requirements into uh, one unit. All right. So as I said, in LAMP stack, right? So you require a Linux, then you require Apache 2, you require MySQL, and you require PHP for hosting a website. All right, all these four requirements, right? So what you can do is create a Docker container which has uh, from an image of Ubuntu, right? So an Ubuntu image of Docker, right? On that, you can have your PHP installed, your MySQL installed, and your Apache 2 installed along with your application. Okay, so all this thing could be bundled into one, and then out of that container, you can make a image. Okay, you can upload an image onto Docker Hub. Okay, now the terms image and containers, you can think in terms of Java as being classes and objects. Your containers are your objects, and your images, Docker images, are your classes. Okay, you can relate to Java in that way. Okay, so uh, your image, Docker image, is nothing but a blueprint of your Docker container. Okay, and your Docker container is nothing but a running instance of your uh, Docker image. Okay, so containerization we'll see using Docker. Okay, Docker and Vagrant are most popular tools to use over here, and that's the description given over there. Then there is continuous monitoring. Continuous monitoring is, as I said, if there is any errors, if there are any errors that occur while the uh, while the application is running live. Okay, so those errors should be notified immediately to the system administrator, and that is the use of that is the responsibility of uh, these tools such as Nagios. Okay, popular tools are Splunk, ELK, Stack, Nagios, New Relic, and Sensu, but Nagios is very famous. Okay, but we won't see this tool too because it's not in our syllabus, and that will be a whole lot to cover, right? So that was a brief description of what DevOps is on all the stages involved in DevOps.